All right, good afternoon, everybody. It is Thursday, March 9th, late afternoon here, and in this video we're going to be talking about the possibility of a potentially major winter storm impacting the Northeast next Tuesday, possibly even next Tuesday into Wednesday if certain factors come together. Right now, this is just the visible satellite of the Northeast. Very windy day today. Out in front of a cold front where we're going to have actually a little snow event tomorrow on Friday. It's going to develop, and I can show you that as we run through here. But what I want to do specific is I want to run through the European model and what it showed this afternoon, because I think it showed several interesting things. And so this is the surface map right now, which we can look at and run it forward. This is for tomorrow morning. You can see some snow developing over Pennsylvania, over in that area, and that is going to overspread southern New England to the east. So New York City, Connecticut, Rhode Island, Southeast Massachusetts are going to get decent snows, maybe 4 to 6 inches in many of those areas, probably the most common totals. And then that exits stage left, or excuse me, stage right, off the Atlantic coast. But what's really interesting is what happens behind that. So here you can now keep your eye on the northern plains here. You're going to see a system. It's going to dive out of that region, head towards Oklahoma, Arkansas, the Gulf Coast. See, down here it starts to develop. This is a storm that originally, a week ago, a lot of the models were predicting was going to pump up through the Ohio Valley and go into the Northeast. But what has happened is this bitterly cold air mass, depicted by the purples over here in eastern Canada, even stretching into northern New England, is going to crush that system and suppress it to the south. Here it is in the south. It gets mostly sheared apart. It's just a long, stretched out wave of shower activity along the Gulf Coast. But as we run this forward through Sunday and into Monday, what you're going to notice is going to happen here, some of the energy gets left behind us. You got one blob sitting here off the east coast of Florida, another little bit sitting here along the Gulf Coast here south of Louisiana and Mississippi. And this is where things get really interesting, because as the European model leaves this energy behind, this is where you set up potentially something historical if all the pieces come together. So I'm going to take this map here and I'm going to switch. This is from the surface map. This is trying to predict, what the precipitation is going to look like, what you would normally see on a radar or something like that in real time, to what the model shows, what we call the 500 millibar energy map. This is the map here that is used to predict, the weather. This map here essentially creates the surface map that you just saw, that you were looking at before a minute ago. This map right here is the key. Nothing happens on the surface map without this map right here. And the reason why this is so important is this map is showing 3 pieces of energy. Now, along the Gulf Coast is where you see the energy that was left behind from the suppressed wave, sitting along the Gulf Coast and trying to form a little low down there. And we all know it's very dangerous if you track winter storms, because this is where your big lows, your big storms can come from. And you have something possibly originating down there. So you got a little bit of energy. Not much, but enough that the European model is showing a low. And then behind that, we have another piece of energy sitting out here over the plains of Kansas, Missouri, Iowa, Nebraska. That energy is diving towards the east-southeast at this stage. And then, if that wasn't enough, we had a third piece of energy up here over Manitoba and Western Ontario. This, as we run forward, is going to break off from this piece over here over southern Quebec and New England. This is going to break off and head away. And what we're looking at is, if you're looking for something historical, are these 3 pieces going to come together? And so now I'm going to switch, and I'm going to take this off here, and I'm going to switch over to a map that is going to show us this in motion. So here's our 3 pieces of energy that we just looked at. One along the Gulf Coast, one along the plains, and then one over here in southern Canada. And as we play it forward, watch the 2 pieces here in the north. You can see the Canadian piece here trying to dive toward that plains piece as it moves east. And notice how they try to interact, but they don't completely get together. You got one now, this piece that was over the plains, now over the Appalachians. The northern piece is now diving into the Great Lakes. And then you have this other piece swinging out over here towards the east. It's very close as we play it forward. Now, as you watch this map over here, notice how you got most of the energy back over here over the Great Lakes and the Ohio Valley, and then another piece of energy over to the east, off of these coasts. Now, if we play the surface map, because remember, this map here creates the surface map, or at least it's supposed to, in most cases, we can now run this forward and watch what happens with our storm along the Gulf Coast now. So you see, you get some precipitation, it develops off Florida, off the Carolina coast, and now you really got your low pressure going. See, now it's a bona fide low pressure right off Cape Hatteras at hour 1:20. That is Tuesday morning is what this corresponds to. Snow breaking out over Maryland, Pennsylvania, New Jersey at this stage. But if we switch back again to our 500 millibar map, and actually let's go 6 hours back here so they match up. So we're now at 120 for the surface, 120 for 500 millibar. Notice our storm is on Cape Hatteras at hour 120. So that storm is being created by this piece of energy that is sitting off of the North Carolina coast. It has not tapped into all of this energy that is sitting back over the Ohio Valley and the Great Lakes region. And this is really the bulk of the energy. So again, as we play it forward, we're going to play the 500 millibar map forward, 12 hours here, 6 hours there, 12 hours there. We see this trough really digging in now over the Ohio Valley with this other piece hanging off of southeastern New England. And again, we can go back to the surface map here and show how that plays out here. Watch the storm. It's going to go from Cape Hatteras here and then start. I'm going to zoom in here on it just so we can get a little bit of a closer view. And there it goes northeast from there. And then let's go even further northeast from there. And you can see now you've got a storm. It's all the way down to about 984 millibars at this stage. Big high pressure to the north. You can see precipitation reaching back across Pennsylvania, New Jersey, New York State, and New England. And your low is pretty close to the benchmark here, off to the southeast of New England. And notice that where the low is there matches almost perfectly to where this piece of energy is hanging off of the New England coast here. The reason why I am showing this map and the reason why it is so important to understand this is that if this energy is tucked back further to the west along the coast, either that or if this energy over the Great Lakes dives in more aggressively and is over the Appalachians or Pennsylvania or West Virginia or Western Maryland instead of being way over here, all of this energy is going to bundle together. Again, I can run this forward and watch what happens. This Great Lakes piece of energy is going to continue to dig and what we call cut off and become a closed low pressure. You're going to see this in a second. And then this piece is going to go up into the Gulf of Maine and try to do the same thing. 138 here. So this is now Tuesday night. And then we move into Wednesday morning. Notice this now. We have two closed low pressures here at 500 millibar. This piece up here in the Gulf of Maine is what the storm showed on the European model today. And then this piece is a whole bunch of additional energy that the European model did not fully allow the storm to tap into because they didn't completely phase. Again, going back to the surface map, we're going to zoom in some more now, and you can see our storm here. It explodes over the Gulf of Maine. Even so, this would be a huge storm over Rhode Island and eastern Massachusetts. These colors here are extremely heavy snow. Low pressure now bombing into the 970s and then heading up into the Gulf of Maine with very heavy snows continuing throughout all of eastern New England. This would be well over a foot of snow just if this solution verified verbatim. But the point I want to emphasize and hammer home here is that even under this scenario, where you can clearly see all of this energy back over Pennsylvania, Ohio, the Virginias, Maryland, getting left behind, it produced a storm that's going to dump well over a foot of snow for much of New England, Long Island, up into Nova Scotia, New Brunswick. If either the original low off of Carolina is further west, or if the energy that dives in behind is further east, all of this energy is going to phase together in what we call a triple phaser. So we go all the way back to the beginning. Remember, here are our three pieces of energy. You get the right hour here. 9:06 Monday. This is Monday morning. Our three pieces of energy which we highlighted: southeast energy, plains energy, Arctic energy diving down from Canada. If all three of these phase, now again, I'll just run this, at any given moment here, right? So these two pieces over the plains try to phase together, but what I really think think needs to happen to get a triple phase here is this energy that's coming into Minnesota now needs to dig more toward, let's say, Indiana and the southern part of Lake Michigan. Because that would do two things. Number one, it would phase this energy quicker. And if it phased quicker, if you notice right now, we have what's called a positively tilted trough. And what that means, if you look at these numbers here, 522, 528, 534 thicknesses here, they are pointed from, let's say, 1 o'clock towards 7 o'clock, or 2 o'clock towards 8 o'clock, if you were to go from the lower to the higher thicknesses here. And what that essentially means is that the pieces moving along the North American continent can still move west to east pretty quickly, particularly to the south of them, when you have this setup. If we had a negatively tilted trough, which is sort of weird because we sort of have that with this piece down here, if you look at the thicknesses down at 552, 558, 564 over Kentucky, Tennessee, and Alabama, that means they're pointed negatively tilted where we see it stretching, let's say, from 11 o'clock down to 5 o'clock. Right? So you've got one trough orientation up here over the Canadian border in Minnesota and Wisconsin, and another one down over the Ohio and Tennessee valleys are approaching it. These need to essentially line up. This system up here needs to dig further south so it aligns with this one down here, phases this energy faster, and is able to swing these two little troughs into one big one that swings negative. If that happens, it is going to catch. So instead of being back over here, where it's still hanging out over the Great Lakes, hasn't moved. Notice how it doesn't really move that much in these 12 hours here. It's still kind of stuck back over Wisconsin and Michigan. That would then swing it, instead of from the western Great Lakes, over into the eastern Great Lakes, and then it would be close enough to pick up this energy that's off of North Carolina. And remember, I'm going to go back to the surface here and backtrack to hour 120. Remember, this is where it corresponds to our storm really getting going. Off of the Carolina coast, this is where all the moisture supply is from the Gulf of Mexico and up the Gulf Stream and the Atlantic. If that is able to be captured by all of this, you are going to have an explosive result over the entire northeastern corridor, and the snow is going to be measured in feet. Again, we just missed a triple phaser on this afternoon's run of the European, and it still produced over a foot of snow for much of Long Island and New England. So you can only imagine what's going to happen if we get a triple phaser. I'm not saying it's likely. One of the pieces probably will not cooperate. I would not predict it at this. I would predict a significant snowstorm. I wouldn't necessarily predict the triple phaser. But if you do get a triple phaser, the ceiling of this event is nothing short of historical. All right, that's all for now. Have a good day, everyone.